Hello friends, welcome to today's operating system class, and today's class we will discuss the operations on process, and that will come under second unit. Okay, in this lecture we will see the process creation and process termination. These two are the operations that will be performed on process. As we have already seen in the multi-programming system or the time-sharing system, more number of process can execute simultaneously by this operating system. Hence, it is necessary to create or delete the process dynamically. Hence, there are two operations. First one is process creation and process termination, which is always called as deletion. Hence, the creation and deletion will be taken place dynamically. In process execution, a process may create several new processes. Okay, as per our example, a process A which is in execution. So during its execution, the A will create the process B and process C. Hence, B and C are children of this A. A is a parent, and B and C are children of that process. So child, and this C is also child of A, right? Okay, and each of these new process may in turn create other processes. See here, B, during the execution of B, the process B will create D, E and F. Okay, other processes also be created while the execution. Hence, this will create a tree of process. Okay, tree of processes. This is the process tree. Okay, and all the process are identified by process identifier. This is a unique number. Normally this is the integer number, and this is the example tree of process for Linux system. This is our topmost parent, root parent. Init is our parent, and all the process is having its own process ID, that is PID, and the number should be integer number. See, for every process it is having its own PID. Okay, by using PID only we can refer that particular process. Here init is our parent process, and this will create the login, kthread and sshd processes. Okay, again this login will create, this process will create the bash process, and bash is having two children. First one is ps and emacs. Okay, and all the process is having its own PID, and normally this is a number, unique number. A unique number will be assigned to all the processes, and we are going to refer the process only by means of this unique ID, that is PID. When parent create a new process, then the possibilities of execution are: first one, the parent and child can execute concurrently, or second possibility is the parent will wait until the children will be completed its execution and terminated. Up to that the parent should wait. Okay, so these two are the execution possibilities of parent and children. And second one, the address space possibilities of parent and children. The first one, the child process may be the duplicate of parent process. For example, we can use fork command, then the child will be exactly the copy of parent. Okay, this is first possibility. And second one, the child may have its own new program. Okay, that may be loaded and executed. That is not the copy of parent. So these two are the address space possibilities of parent and child processes. Next, let us see the resource allocation to child processes. That is, when parent process creates a new process, that is the child process, then immediately we need to allocate certain resources for executing the child process task. What are the resources we have? CPU time, memory, files, that is data files, and IO devices, and etc. So these are all resources, some of the resources to execute the child process, right? The child process task, right? Here the child process be able to obtain its resources directly from the operating system. So the operating system can directly allocate resources to the child process, or it may take some subset of parent process resources. Okay, it can take some resources from parent directly. Okay, so the parent have to partition its resources among its children. So parent have to allocate the resources, or it gives some portion of resources to the child, or it may share some of the resources, only some of the resources, that means a memory or files for executing the child processes. And next let us see how the process will be created by using the fork system call. Right here, this is our parent process. This process will create a child by using the fork system call. Okay, so the fork will give the integer value, that is PID value, process ID. If we use this fork, then the child process will be exactly copy of the parent process. Okay, if PID equal to 0, then this will be the child process. Okay, again we need to give another process to the child. So EXEC, we are going to assign some other task to the child process, right? Execute some command, for example ls command, right? So once the command is being executed, then we have to exit this child process. So exit will terminate the child process, right? Then if the PID is greater than 0, then that will be the parent process. This will be the parent process. Then the parent have to wait until the child will complete its execution. So by using this wait command, we have to keep the parent wait until the child execution completed. Then the parent resumes its own process, right? And this is the simple C program to explain this fork system call. In this program, this is our main method. Here, by using this fork, we have to create a child process PID, which is equal to fork function. If PID greater than 0, then the fork is failed, that is we cannot create the child process. Hence error occurred, fork failed, then we have to return 1. That will return to the main program. Otherwise, if PID equal to 0, then child created, our child got created. Now what we have to do? We have to execute some other, that is we have to assign some other process to the child process, isn't it? EXECLP is the equivalent to EXEC system call, right? Which is equal to, first, this one is the location of the command, and ls is the command. What the purpose of ls command? That is used to list all the files and directories in the given directory. Okay, and null is the return type. Null is the return value. Okay, this is the execlp command. So in the execlp command, we are having 3 parameters. First one is location. All the commands will be located in bin directory only. So bin /ls, and ls is our command, and null is the return type, return value. Okay, this will return nothing. And next else. Else means if the PID value greater than 1, greater than 0. Okay, PID greater than 0, then that is the parent. So the parent should wait until child will be completed, child process completed. Then the print statement that will give child completed. Okay, so here we are having 3 conditions. First one is PID less than 0. If PID is less than 0 means the child is not yet created, fork failed. Okay, child will not be created. And second condition, PID is equal to 0. If PID is equal to 0 means the child is created. And third one is PID greater than 0. If PID value greater than 0 means that is the parent process. The next operation is process termination. Once the process completed its execution, then the process will be terminated by using the exit system call. Okay, the operating system will use the exit system call to terminate the process. Here the process will return the status value, that is, before exiting the process will return the status value to its parent. Okay, and by using the wait system call, and all the resources of process, that means the resources will be allocated to those process for execution, isn't it? Those resources will be deallocated by the operating system. See, once the process got completed its execution. So what are the resources here? The physical as well as virtual resources like memory, open files, IO buffers, etc. Everything will be deallocated by the operating system. The parent may terminate the execution of child process for three reasons. First one is, if the child exceeds the usage of resources, then the child process can be terminated. And second one, the task which is assigned to child is no longer required. And third one is, if parent exit, then the OS never allow the child to be continue if parent is terminated. That is, if parent is terminated means before that all the parent children should be terminated, then only the parent will be terminated. Suppose if the parent is being terminated, then the OS will not allow the child to execute further. If a parent process terminates either normally or abnormally, then all its children must also be terminated, and this process is called as cascading termination, which is normally initiated by the operating system. Okay, so if a parent wanted to terminate means all of its children should also be terminated before the parent terminates. Okay, then this is called as cascading termination. Up to this we have seen the operations on process. The first one is process creation and process termination. That will come under second unit, process concept. And now this is the question time. What is the purpose of fork and exec system call? Students, please write your answer on the comment box. And in the next class we will see another important topic from second unit. Thank you.